Hi, welcome to this video series on visualizing regular expression using Automata. We looked into how to analyze regular expressions in the previous segment. However, we didn't focus on some corner cases that I think worth clarifying. For example, if you look at the regular expression that I am sharing currently, let's see, it looks like it will accept any number of AB, right? That's the reason for this AB followed by a plus. Okay, let me show you what is the meaning of cap followed by dollar very quickly. Cap followed by dollar means empty, right? Nothing. So the only thing that it should accept is an empty string. So for example, as you can see here, empty string is the only string that the machine will accept. We are at state 0 and that state is accepting state. Okay, there is no input. As you can see, there's no label on the transition name. That means only empty states, empty inputs are accepted. Okay, this is how we interpret this this model. When you see double circle, it means acceptance states, right? This state is accepting state as well as initial state, because there's an arrow mark pointing to it. Okay, let's move on to the example that I would like to talk about is this one, right? AB plus. Okay, so this looks like nice graph, right? You start at state 0. Okay, let me write it here. What is the goal of this automaton? The goal of this automaton is to recognize A followed by B one or more times, right? So if you feed in A, okay, let's assume our input is just AB. So will this accept? Let's see. We are at state 0 to start with. We read an A. Yes, nice. We reach state 1. And then we read a B. Very nice. We reach state 5. Okay, and state 5 is an accepting state because we see 2 circles. Okay, or 2 ovals. Okay. This means that this is accepted. Okay, but the question now is, what about A, B, and B? How does this work? With A, B, we know we reach state number 5. Although at state number 5 we have 2 ovals, now we have an extra B. What shall we do with this B? We look at the outgoing transition from state 5. There's only one outgoing transition. Okay, the outgoing transition is to state 4 using the label A. Okay, but the label we have is B. So what can we do now? Well, in this case, the way we interpret this is as follows. At any state, we look at the outgoing transitions. If none of the outgoing transitions matches the label, then we go into a special state called error state. Okay, so we can imagine there's something called an error state. Okay, what it means is that anything other than the planned one, like, okay, the model says from 5 I can only accept A. That means anything other than A should go to the error state. The same with state 1 also. Let's say the input was AA. Okay, what happened in that case? First A will bring us to the state number 1, and then we look at 1. The only thing we accept is B. Okay, so if A is coming, that means we should go to the error state. So this is how we wanted to interpret things that we didn't explicitly model or explicitly see as part of the state machine. Okay, so it is to be too boring for all these connections to go to error state, because it's just too many arrow marks. So that's the reason we implicitly leave out the error state. Okay, so to summarize, if you feed in AA, this is not going to be accepted, because the first A will take you to state 1, and the next A is actually not modeled. That means it will go to the error state. Okay, error state. All right, what about AAB? Of course, it's also error state, because it's already, as soon as you see an A, it goes to error state. Let's look at the other example now. A, B, AB. Okay, well, this is good, because AB will bring us to state number 5, and then we have an outgoing A, so, and we can go here. And now we have a B, that means we can go here. So this is good. But what about A, B, AA? Same story. AB brings us to state number 5, and now next A brings us to state number 4. But then at 4, we only accept B. That means we go to error state. Again, this is how we interpret how the automata behaves for our inputs. Okay, that's basically it. Thank you very much.